In this video, we're going to address finding x and y intercepts, both graphically and algebraically, but some simple algebra. So an x-intercept is where the graph crosses or touches the x-axis, and a y-intercept is where the graph crosses or touches the y-axis. Just as a reminder, on the coordinate plane, the x-axis is the horizontal line and the y-axis is the vertical line. So let's look at this linear function and find the x and y intercepts. Now, not all graphs have both. Sometimes the graph only has one or the other. So in this particular graph, let's start with the x-intercept. I'm going to look along the x-axis, this one, and I'm going to see where the red line crosses the x-axis. Well, it crosses here. So to figure out where that is, I'm going to count the tick marks. I notice that this is -5, so the next one must be -6. So the x-intercept is at -6, 0. Or you can tell me the x-intercept is x equals -6. But I need you to be very specific about what information you're giving me. You can either give me the ordered pair -6, 0. Remember, in an ordered pair, the first number is x and the second number is y. Or you can tell me the x-intercept is x equals -6. The y-intercept, where it crosses the y-axis, if you count the tick marks, you're going to find out that's at 4. So either you can tell me it's the ordered pair 0, 4, or you can say the y-intercept is at y equals 4. It is not acceptable to say the answer is 4 without being very clear about what information you're giving the reader. Let's look at this quadratic. The x-intercepts, there are 2 of them. The graph hits the x-axis here and here. This is at x equals 1, and this is at x equals 5. Or you can tell me they are at 1, 0, 5, 0. The y-intercept, this is where the graph hits the y-axis, and that's at y equals 5. Or you can tell me that it's at 0, 5. Let's try it again. In this absolute value function, I want you to see that it hits the x-axis twice. If I count the tick marks, this one here is at x equals 3, or 3, 0. And this one here is at x equals -9, or -9, 0. The y-intercept is here at y equals 3, which is the ordered pair 0, 3. In this one, the x-intercept is here at x equals -3, or -3, 0. And the y-intercept is here at y equals 1, or 0, 1. There is a way we learned in Algebra 1 for finding x and y intercepts. We usually like to do them with linear equations, but we can also do them with quadratic equations. One of the things we noticed from the x-intercepts was that in every ordered pair, y was 0. So if you replace y with 0, you can algebraically find an x-intercept. 2 times 0 is 0. 2x plus 0 is just 2x, because if you add nothing to 2x, it doesn't change it. And then the last step in this problem, because this is 2 times x, the inverse operation is to divide. And we find out that x is 3. So 3, 0 would be the x-intercept. The y-intercept, the x-coordinate of all of our y-intercepts was 0. So we'll plug in 0 for x. Oops, make that look nicer. 2 times 0 plus 3y equals 6. I'm going to skip a step here. I'm going to cross this off. The reason I'm crossing it off is because 2 times 0 is 0. And adding 0 to anything does not change the problem. You're really just left with 3y equals 6. Remember, that's 3 times y, so you solve by dividing by 3, and 6 divided by 3 is 2. So the ordered pair is 0, 2. We can also do this with a quadratic equation. So if I gave you the equation y equals x squared plus 6x plus 8, if I wanted to find the x-intercept, I could just make y equals 0. Now this requires a little bit more work that we haven't reviewed yet, although you've done it in Algebra 2. So we're going to skip that for now. But finding the y-intercept when you plug in 0 for x is really easy, because what's 0 squared? Well, it's 0. What's 6 times 0? Well, it's 0. These end up going away because they're both equal to 0, and you find out y equals 8. So the y-intercept ends up being the last number in the quadratic equation. This number was called the constant. And that is a review of finding x and y intercepts.